to this Pathfinder solution series. Today we'll be solving problem from fluid mechanics. This is question number 19 of build up your understanding. I would say you to read the question and give it a try before looking into the solution if you have first look on it and just then look at my solution. So what does the question read? It says that two objects of equal volume V and density ρ1 and ρ2 have identical flat portions of area S on their surfaces. These flat portions are glued to each other. The composite body thus formed floats fully submerged in the liquid with the common flat portion horizontal as shown in the figure. If the glue was can withstand maximum force F, at what minimum depth in the liquid can the common flat portion be in equilibrium keeping the objects intact? Acceleration of free fall is G. So we need to analyze what is given in the question. Just redrawing the diagram. This is of row 2, this is of row 1. This common area is S. This is up to a depth H. Now if I want to find H, the first thing that strikes in my mind is that I must draw the FBD of any one part of the composite body, either this part or this part. Any part I draw the FBD and then I may get some solution for H. So let's start with this motivation. So I'm interested in any of the body. Let's say I'm interested in the lower body and I want to find the force on the CSA of this particle. So there is nothing. So if I want to find the force on the CSA, it is irrespective of the fact that what is inside this one is what is the density of the it doesn't depend on what is there inside this part. The force doesn't define is not dependent on this. It is dependent on the configuration of the object. So if I consider the same bucket and the same object with the same configuration, but it's made up of water. So I know its volume is V and the density of water I think is given. No, it's not given. So if I take it as the row of the, is it given let us take it as the row of the liquid. I don't know what is it. So the weight given by it will be rho LVG. The the pressure acting on this will be P naught plus, okay, one thing is that while I have done this solution before, but uh, here one thing is missing is that P naught must be neglected. That is, the atmospheric pressure must be neglected. So at this point, as it is at the depth H, and right, it is rho L GH times S is the force acting on this, and this is the FCSA. FCSA is acting on this. So as this whole object is in equilibrium, you can write rho LGHS minus J cap, and the net force must be 0 in the vector addition. So FCSA must be rho L VG rho L GH times S in the J cap direction. Next, I'm interested to draw the FBD of this rho 2 mass. So see, as these two objects are glued together, this glue will have a force on this object in the upward direction. It will be pulling it upward to hold it with this object. So the force on it is in the upward direction. That means the given force, this is the given force, this is the given force, that will be upward in this direction. Next, there is FCSA by the liquid, which is irrespective of the fact what is there inside this. So I may consider this and this are the same thing. This is in the g cap direction, and this is the weight of, there is a weight of the fluid, sorry, the particle, that is rho 2 vg, and there is a pressure, that is rho l, sorry, rho l g h times s. Sorry, it won't be there, it won't be there, because this liquid is not seeping into this portion, liquid is not seeping into this portion, so I cannot put this force here, because liquid is not there in this portion. That means the cross sectional area over which these are glued, liquid is not present in this portion, so there be no such pressure forces. So I want to balance this FBD. Finally can write F plus FCSA is rho L Vg plus rho L GH times S, and that gives you rho L Vg, so rho 2 Vg. So F minus rho 2 Vg plus rho L Vg, okay, I should take that in. ठीक है, तो H हमारा इधर से क्या आ जाएगा, रो 2 Vg रो L Vg माइनस F और डिवाइड बाई रो L GS। ओके, ना अब देखिए, अब कुछ नहीं है, अब तो आराम से ही हो जाएगा। अब इस जो ये जो चीज़ है, इसमें कुछ बाउंड फोर्स लग रही होगी, इससे अब रो एल और रो वन रो टू के बीच में एक रिलेशन आ जाएगा। तो इसका वेट क्या लग रहा होगा, रो वन वी जी, इसका लग रहा होगा रो टू वी जी, एंड दैट मस्ट बी given balanced by the bound force, that is rho L 2 Vg. So I can write them equal, so I'll get rho 1 plus rho 2 by 2 is rho L, rho L है ना, हाँ ठीक है, rho L. Just I'm equating this two with them, I'll be getting this equation. Rho L is rho 1 plus rho 2 by 2, so H is rho L GS, then sorry, rho L can be written as rho 1 plus rho 2 by 2 GS rho 2 Vg minus rho 1 plus rho 2 by 2 Vg minus F, and get the 2 out and this Vg in common, I'll get 2 rho 2 minus rho 1 minus rho 2 will give me rho 2 minus rho 1 by 2 minus F by rho 1 plus rho 2 by 2 into G times S, G times S I think, so S G times S. So this is rho 1 plus rho 2, taking the 2 up, multiplying to the numerator and denominator by 2, rho 2 minus rho 1 minus 2F, and that's a good place to stop.